Number 8. A sample thought to be pure lead occupies a volume of 15.0 milliliters and has a mass of 160.0 grams. Determine its density. Well, I'm hoping that we remember that density is equal to mass divided by volume. We have a volume, we have a mass. Let's plug them in. So the mass here is 160.0 grams. The volume here is 15.0 mils. And before I go anywhere, I got 3 significant figures here, and I have 4 significant figures here. So I'm going to report my answer with three significant figures. I know that the grams and milliliters can't cancel out, so my units will be grams per milliliter. But what does the calculator say this value should be? 160.0 divided by 15.0. Now I've got to put this to 3 significant figures. So that'd be right here. That means that this 6 is telling me to round this up to 10.7. 10.7 grams per milliliter. Is the sample pure lead? Refer to table 4. So let's take a look at table 4. Let's find lead. The density of lead, okay, at standard conditions is 11.37. 11.37 is the density of lead. Is that the density of the substance that we just looked at? No, this is less than the density of lead. Okay, do we know what it is, like what it actually is? No, we don't. It might be pure something else. It might be a mixture of something, but at least we know for sure that it's not pure lead. So what we say here is no. Determine the percentage error based on the accepted value for the density of lead. So let's remind ourselves, what was that accepted value? 11.35 grams per milliliter. All right, so calculate the percent error. So percent error, we're going to take the accepted value. So that's value accepted, subtract value experimental, like what we actually got, and we're going to divide by value accepted. So we have 11.35 minus 10.7, all divided by 11.35. All that's left to do, tilt that in there, is my calculation. 11.35 minus 10.7, all divided by 11.35. Now this is a decimal. I need to multiply it by 100% to actually get a percentage. Yep, 5.7. Let's see, three significant figures here. So I'll just leave it with 5.73%. Let's see. Yep, 5.73%. Actually, no, hold on. We did some addition here. Yes, because this value right here. Aha, I almost messed my own self up. Let's see, let's correct my error here. 11.35 minus 10.7. Now, you guys see that this value can only have one place past the decimal, right? Because I'm doing addition and subtraction. So I'm going to round that up to 0.7. So 0.7 divided by 11.35. In this situation, I only want I want to have an answer that's actually closer to 6 here. Yeah, I know that's not hugely different, but when it comes to selecting answers, considering the appropriate number of significant figures at each step, is going to make a big impact towards getting yourself the correct answer. But the main thing I'm assessing here is whether or not you remember the percentage area equation. We also need the appropriate number of significant figures, so really the better answer here is going to be 6.1%. But if you get the 5.73, I'm at least happy with that because you definitely know the percent area equation.